Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today we're going to start with the new topic, which is Introduction to Probability. So in Introduction to Probability, we will learn first is counting rule, how to count, and then we will start with the revision on set theory, and then we will start with the Introduction to Probability. We will learn Bayes theorem and tree diagram, right? So now let's start with the counting rule. In counting rule, in determining the number of outcome that can occur for a particular experiment, we need to count, right? So if you want to know how many outcome in particular experiment, we need to do a counting, right? In statistics, there are some rules that can be used for counting purpose, right? So now the first rule, right, if we have a task can be done in m ways, right? M means some numbers, right? And another task can be done in n ways. So then we can do the task with m multiplied with n ways, right? So this is the rule of counting method, right? So if let's say for example you have for a simple experiment, let's say you have shoe, and another one is you have shirt, right? So you have one shoe A, B, and C, right? And then you have shirt 1, 2, 3, right? So if you want to know how many possible outcome, right? How many pair shoes A, or you can choose either shoe A or shirt 1, shoe A, shirt 2, shoe A, shirt 3, right? So this is the possible outcome. If you want to know how many possible outcome, let's say shoe A, a shoe you have 3 alternative. Let's say you have A, B, and C, and shirt you have 3 alternative as well, n equal to 3. So how many possible outcome? N equal to 3 multiplied with n equal to 3. So 3 multiplied with 3 equal to 9. So you have 9 alternative to choose different shoes and different shirt, right? So this rule can also be extended to more than 2 tasks. It is sometimes known as m multiplied with n counting rule. So if you have more than 3 tasks, more than 2 tasks, let's say you have another one is let's say you have pens, right? So you have, let's say 1, 2, 3, 4 type of pens to choose, right, to pair with shoe and shirt, right? Let's say this is m equal to 4. So if you want to know how many possible outcome you have to choose between shoes, shirt, and pants, so you just need to multiply 3 possible outcome for shoes, multiply with 3 possible outcome for shirt, multiply with 4 possible outcome for pants, right? So you will get the value, the amount of possible combination, right? 3 multiply with 3 multiply with 4. So you have basically 36 possible outcome. Means you have 36 alternative to choose from 3 different shoes, 3 different shirt, and 4 different pants. For example, if you choose shoe A, shirt 1, pants number 1, you can also choose shoe A, shirt number 2, pants number 2. So altogether there are 36 possible alternative, right? So another rule that available in counting rule, right? If a task has r possibilities to be accomplished, then the number of ways to accomplish the same task for n times is r power of n, right? So in this case, the task is done with replacement. For example, for this theorem, this example, if you have let's say 10 question, 10 true false question, right? So the first question you can choose either true or false. The second question you can choose either true or false, right? So now to know how many possible outcome from question 1 until question 10, right? So you just need to apply the second formula, which is you have 2 power of 10, right? So you have basically 2 power of 10 is 1024 possible outcome, right? Because the first question you have 2 possible outcome, you can choose either true or false. The second question you also can choose either true or false. So basically for 10 question you have 2 power of 10, right? So basically the second formula also related to the first formula, right? Because the first task you have 2 possible outcome, the second task you also have 2 possible outcome until the 10th task, right? You just need to use, if you apply the first formula, the first task you have 2 possible outcome, second task 2 possible outcome until the 10th task also 2 possible outcome. Basically, if you do a summarization using a mathematical theory, you will get 2 power of 10, right? Because each task, each question having a same possible outcome, right? So let's look at the formula number 3. The number of ways to arrange n different object is n factorial, right? The symbol of factorial is read as a factorial, right? N factorial is equal to n multiplied with n minus 1, n minus 2, n minus 3 until 1, right? So therefore, if you have 5 factorial, it should be 5 multiplied with 4 multiplied with 3, 2 and 1. For this example, for this theorem, for this formula, there is a condition, right? The number of ways to arrange n different object is n factorial. Different object means you should not have a repeated object. For example, let's say if you want to, let's say I put this way, if you want to rearrange the word nase, right? So nase, N-A-S-I-R, all together we have n equal to 5, right? So if you look at each word, each letter, it has different object, right? So there are no repeated object with for the word nase, right? So if you don't have any repeated object, and which is you have a different object for this word, so if you want to do a recombination, right? If you want to rearrange the word nase, you will have n factorial, which is 5 factorial. You have 120 possible outcome. Means you can rearrange n, a, s, r, i, right, and so on lah. So you can do 120 times, right? So that is for formula number 3, right? For formula number 4, right, the number of ways to arrange R1 different object, R2 different object until Rn different object from n different object is n factorial divided by R1 factorial multiply with R2 factorial until Rn factorial, right? For this example, for formula number 4, right, let's say for formula number 3, you know that if you have a different object, right? For formula number 4, let's say you have a repeated object. Right? If let's say the word of roll, ROLLED, right? If you want to rearrange the word roll, let's say in the word roll you have how many objects? 1, 2, 3, 4, 5, 6. You have 6 objects in the word roll. You have basically 6 letters lah in the word roll. If you want to rearrange the word roll, how you want to know how many possible outcomes are there, right? So by looking at the word roll, you have 2 repeated letter, which is L, right? So let's say we put N for R is equal to 1, and O also having 1 object appear, and L you have 2 objects, and E you have 1, and D also 1, right? So by using the formula number 4, formula number 4 says that n factorial divided by r1 factorial multiply with r2 factorial until rk factorial, rn factorial, right? So the formula, the number of all possible outcome is 6 factorial divided by number of r1, which is 1 factorial, number of o also multiply with 1 factorial, this is for o, and the third one is for L, which is 2 factorial multiply with 1 factorial, 1 factorial, right? If you need to know, 1 factorial is also equal to 1, right? So this formula can be simplified to 6 factorial divided by 2 factorial, right? So by using the calculator, 6 factorial, right, 6 factorial divided by 2 factorial, it should be equal to 360. So there are 360 possible way to rearrange the word roll, right? So basically there are 4 formula you need to remember, right? The first formula is M multiply with N, right? If you have 2 tasks, you have a task, the first one can be done in M ways, the second one can be done in N ways, so the whole task can be done in M multiply with N ways, right? Provided this task having different or unique alternative for each task, right? Means for shoe, this is the example for number 1, right? For shoe, you have a different pair of shoes, right? You cannot have a replicated pair of shoes or same or repeated object. For shirt also, you should have the same, and you should have a different shirt, right? So then you can use M multiply with N counting rule. For a second formula, if you have R possibilities to accomplish the task, then the number of ways to accomplish the same task for n time is R power of n. So this is my example is for question true and false, right? For the first question, you have 2 possible outcome. The second question, you have 2 possible outcome. So you also can use the first formula to accomplish this example, right? But because of we have the same or repeated possible outcome for each task, right? You can simplify using a mathematical theorem, which is 2 power of n, right? So that's why the formula number 2 is coming, right? For formula number 3, if you have n different object, right? So if you want to rearrange that object, right? So you can use n factorial, right? Because you have different object. If you have a repeated object, so you need to use this formula, right? So So far, for these four, boleh faham tak? Right? Boleh comment sikit? Right, very good. Right, very simple formula, right? So now, let's look at example number 7.19. 7.19. So in example number 7.19, so a lady has 4 dress and 6 tudungs that can be choose to wear for a day. So this is example yang I bagi tadi kan. So she have 4 dresses and 6 tudungs that can be choose to wear for a day. So how many different outfit can she wear for that day? So if you look at this one, for dresses she has 4, for tudung she has 6. So basically this is a different dresses, and this is also different tudung. So you can know how many different outfit can she wear by using the first formula, which is 4 multiplied with 6, which is equal to 24. Right. So for this topic, you need to pay more attention. Right. This is a bit tricky and not really straightforward. Right. So now look at example number 7.20. In example number 7.20, there are 4 different routes to travel from town A to town B, right? And there are 5 different routes to travel from town B to town C. So we want to know how many different routes can a person travel if he wishes to travel from town A to town C by passing town B, right? So now for this example, right, for town, let's say town A to B, so you have 4 different routes. From town B to C, you also have 5 different routes, right? So now by looking at the first formula, right, if a task can be done in M ways and another task can be done in N ways, then we can use M multiplied with N to accomplish this task. So this one should be equal to how many possible different routes? 4 multiplied with 5. You have 20 possible different routes that a person can choose to travel from town A to town B. Right. So far, boleh faham the first 2 question, right? I try to teach you slow as I can, right? Any questions so far? Ada soalan tak? So basically you understand the first question, right? As the first formula. Now, look at example number 7.21. For example number 7.21, dia kata dekat sini, a coin is tossed 4 times. Find the number of possible outcome for this experiment. So, now, a coin, you have 2 possible outcome, right? Either head or tail, right? For a coin. For a single coin, you have basically 2 possible outcome. If you toss it 4 times, for the first outcome, you have first toss, right? You should have 2 possible outcome. Second toss, you should also have 2 possible outcome. Third toss, you should have also 2 possible outcome, and the fourth toss also having 2 possible outcome. So since each toss is task having same possible outcome, right? For example, this one. So you can use first formula, which is 2 multiplied with 2 multiplied with 2 multiply with 2. So it should be equal to 16. So if you don't want to do a massive calculation, you can use a mathematical theorem to convert this one to 2 power of 4. So also equal to 16. It's the same value, right? So now example number 7.22. This is the same example that I give to you. So you have 2 power of 10, right, which is equal to 1024, right? So don't worry, these notes I will provide to you in Google Classroom. Now, by looking at example number 7.23, in example number 7.23, so we want to know how many ways can 5 letters A, B, C, D and E be arranged. So now, first condition is you need to look at each letter. Is there any repetitive letter, right? So A, B, C, D, E, there are no replicate or repeated object, right? This is a different object, which is distinct object lah. The object are unique, right? So if you have a unique object or different object you want to rearrange, you can use the third formula. The number of way to arrange n different object is n factorial, right? So this one, how many object you have? You have 5 object. So since the object are different or unique object, so you can use the third formula, which is 5 factorial. 5 factorial should be equal to 120, right? So you have 120 ways to rearrange the letter A, B, C, D and E, right? So now look at example number 7.24. In how many ways can the word statistic be rearranged, right? So the word statistics, so you have n equal to 10. You have 10 letters, right? So number of letter S, so you have basically 1, 2, 3. So you have 3 object for letter S. And T 1, 2, 3 juga, right? So you have 3 letter for 3 letter T. And then for NA you have 1 letter. NI basically you have 2 letter, I you ada 2, right? And then NC basically you have 1. So all together you have 10. So since you have a repeated object in the word statistic, right? So you cannot use the third formula. You should use the fourth formula, which is n factorial divided by r1 factorial, r2 factorial, r3 factorial until rn factorial. So r means the number of different object, right? So since you have a repeated object, so it should be 10 factorial divided by 3 factorial multiply with 3 factorial for this one, right? Multiply with 1 factorial multiply with 2 factorial 1 factorial. Tapi you need to remember 1 factorial is equal to 1, right? Any number multiply with 1 should be that number. So this one should be equal to 10 factorial divided by 3 factorial multiply with 3 factorial multiply with 2 factorial. So this one should be equal to 50400, right? So there are 50,400 ways to rearrange the word statistic, right? Okay, now the last example number 7.25. So now In how many ways can a committee consist of chairman, a vice president, a secretary, and a treasurer be formed for 4 nominated members? Right. So basically, you have 4 different position. 4 different position. Let's say, uh, let's say chairman, vice president, secretary, and treasurer. So you can rearrange the 4 members. 4 members, right? Dia akan pilih daripada 4 members, right? So you want to arrange 4 members, and basically members is a human lah. Human should be different, right? So 4 factorial should be equal to 24. So there are 24 ways to arrange 4 members for position chairman, vice president, secretary, and treasurer. Right. So basically, any question for the 4 formula ni boleh faham tak? Right, very good. Semua boleh faham? Kan seorang saja faham. Yang lain tak faham tak? Right. So now we move to the next subtopic, which is a permutation and combination. Now, permutation is an arrangement of a set of object. Permutation is an arrangement of set of object in which the order of arrangement is taken into consideration. Right? So permutation is an arrangement of set of object in which the order of arrangement is important, right? So I ulang sekali lagi, the permutation is the arrangement of a set of object where the order of the arrangement is important. So order is important. So if you want to use the permutation, the number of ways to arrange R object, right, from n different object is n PR n factorial divided by n minus R factorial, right, where the combination is an arrangement of a set of object in which the order of arrangement is not important, right? So the formula for combination is NCR, right, equal to n factorial divided by R factorial multiply with n minus R factorial, right? So basically both formula, combination and permutation, we want to choose R object from n different object. So basically it should have n different object, and this is also having n different object, right? So basically, let's say for example I have 30 students, right? From the 30 students, right, I want to choose 5 students, right? 5 students. So if I just want to randomly choose 5 students out of 30 students, right, and I am choosing randomly the order of choosing or arrangement is not important. The order is not important, means I just nak pilih 5 orang saja out of 30. So this formula and this situation, I can choose combination, right? So this is the first situation. The second situation is I have 30 students, right? I want to choose 5 students out of 30 students. But instead of randomly choose 5 students, right, I want to choose the first student to be a president, the second student to be a vice president, third student become a treasurer, secretary, and others committee, right? So means that the order of arrangement is important. Means the first student should be president, second student should be vice president, third student become treasurer, fourth student become secretary, and fifth student become other committee, right? So means that the order of choosing 5 students is important, right? So if I want to choose 5 students out of 30 different students, right, and the order of arrangement is important, so I need to use permutation. That is how we choose combination and permutation, right? Of course, the formula also different, right? Now, look at example number 7.26. In example number 7.26, the arrangement, find the number of different arrangement to form 4 letters from letter A, B, C, D, E, F, G, and G, right? So A, B, C, D, E, F, G, so N equal to 7. So you have 1, 2, 3, 4, 5, 6, 7. 7 objects. Out of 7 objects, you want to choose R equal to 4 objects. You want to choose 4 objects out of 7 objects. So now, dia kata dekat sini, find the number of different arrangement. So means that in this case, the order is important. Order is important. So when we want to choose 4 objects out of 7 objects, right? And then order is important. So you should choose permutation, which is 7p4, which is also equal to 7 factorial divided by 7 minus 4 factorial, which is also equal to 840. Right? So you have 840 ways to arrange 4 letters, right, out of 7 letters. Right. Now, look at example number 7.27. Find the number of different committees consists of chairman, vice presidents, secretary, and treasurer from 8 members. So this is the same example yang I bagi tadi. So we have n equal to 8. From 8, we want to choose 4 members out of 8, right? So, and then based on this example, the first member should be chairman, second member vice chairman, secretary, and treasurer. So means that this is, in this situation, order is important. So 8 pick 4. So it should be 8 factorial divided by 4 factorial. This one should be 1680. Right? Okay. So now, look at example number 7.28. Right? These two examples is about permutation, and this one is about combination. Find the number of combination consists of 3 letters that can be formed from a letter A, B, C, D, E, F. So basically n equal to 6, right? So you have 6 letters. You want to choose 3 letters out of 6 letters. And the number of the order is not important. You want to randomly select 3 letters from 6 letters, right? So the order of arrangement is not important. So when the order is of arrangement is not important, you just simply use combination. 6 choose 3. So this one should be 6 factorial divided by 3 factorial multiply with 6 minus 3 factorial. So this one should be 20. Right? Very easy. Okay? Now, look at example number 7.29. So, in example number 7.29, find the number of committee consists of 4 committees that can be formed from 8 person. Right? So, this one, dia tak cakap order is important. You just select 4 committees. 4 committees means AJK lah. AJK 1, 2, 3 and 4. It's not really in order. Right? So we have N equal to 8, R equal to 4. Right? So you want to select 4 committees out of 8 person. So we can simply use combination 8 choose 4, which is equal to 8 factorial divided by 4 factorial multiply with 4 factorial equal to 70. Right? So far, before we go further, do you have any question or any question that you want to raise for me? Soalan? Any questions so far? Alright, so now we can move on to example number 7.30. Now, in example number 7.30, find the number of committees that can be formed from 8 men and 4 women if the committee mass of the 5 person must consist of exactly 5 person. Now, we need to understand the statement first. So we have man equal to 8. Let's say, let me use another color. M equal to 8, W equal to 4. So basically N is equal to 12. Men, you ada 8 orang. Woman, you have 4 person. And combination of these two, right, is equal to N equal to 12. Right? Now, the statement says that if a committee of 5 person means you're going to select out of 12, you're going to select R equal to 5. You're going to select 5 out of 12. Right? So now, question A, exactly 5% means that you don't care whether it's woman or man. Right? You just want to randomly pick 5% out of 12%. So this one should be 12 choose 5. Right? So this one should be 7, 9, 2. Right? Because we don't care either it's going to be man or woman. You don't care. The order is not important. We just want to select randomly 5% out of 12%. So we use combination. Now here, right? So we want to select 3 men and 2 women. Right? So in mathematics, when we say 3, when we have AND statement, right? When we have AND statement, it means that we're going to use a multiplication, right? So we try to solve for the first part. We want to select 3 men out of 8 men, right? So we have 8 men. So 8 choose 3, and n means multiply, and 2 women out of 4 women. Right? 2 women out of 4 women. So 4 choose 2. Right? So this one should be equal to 336. And again, we don't care. We don't care about the order. So means that order of arrangement is not important. So that's why we use combination. Right? Now, at least 3 men. So what does it mean? At least 3 men. At least means, right? Either paling kurang, paling banyak 3 lelaki. At least. Paling banyak pula. Paling kurang 3 lelaki. Right? Paling kurang 3 lelaki. At least means paling kurang. Right? So maksudnya either 3 men and 2 women, or 4 men, 1 woman, right? Because we want to select 5 committees saja kan. So the total of these two should be 5 lah. 5, 4 men, 1 woman, or 5 men, 0 woman. Right? So the total of this should be 5. This also 5, 5. Right? So in mathematics, right, when we have AND statement, right, when we have AND statement, it means multiply. When we have OR statement, means plus. Right? So now, let me use another color. So let's say use green. 3 men and 2 women. 3 men and 2 women means 8 choose 3 multiply with 4 choose 2. Very clear. So 8 choose 3 multiply with 4 choose 2. So this is the first part. Right? 3 men and 2 women. Or plus, the second part is 4 men and 1 woman. 8 choose 4 multiply with 1 woman, 4 choose 1. So this is the second part. Or plus 5 men and 0 woman. 8 choose 5 multiply with 4 choose 0. So this is our equation to solve at least 3 men. So this one should be equal to 336, right? Plus, this is going to be 280 plus, and then this is 56. So you should get 672. Right? This is how we solve the problem. Now, the last question is at most 3 women. Paling banyak 3 women saja. Right? So, let me do down here. Right? Paling banyak 3 women. Maksudnya, either 0 woman, 5 men, or 1 woman, 4 men, or 2 women, 3 men, or 3 women, 2 men. Right? At most, paling banyak. So this one should be The first part, 0 woman, 4 choose 0, multiply with 5 men, 8 choose 5. Plus, because this is OR, and this is 4 choose 1, multiply with 8 choose 4, right? Plus 4 choose 2, multiply with 8 choose 3, plus 4 choose 3, multiply with 8 choose 2, right? Let's try to solve this one, you will get the answer. Can you give me the answer for this one? At most 3 women. Can you speak up? Give me the answer. We just click on calculator sajalah. 4 choose 0, multiply with 8 choose 5. This one should be equal to berapa? 7 784. Alright, 784. So this is the answer lah. Right. So basically you understand how to solve this question. So basically this question will be on, this type of question will be on your final assessment lah. Right. Soalan ni tak susah. Alright. So now look at example number 7.31. 7.31, it says that how many 3-digit number can be formed from 2, 4, 6 and 8 if repetition number is allowed. Right. So basically this one a bit tricky, but if you understand the concept, it should not be very difficult. Right. So let me copy this one first. Oops. Right. Hopefully you can see my slide very clear. Now, since kita tak ada space sangat pun tak apa, no worries. Let me use another color. Right. For example number 7.31. Right. Let's see, I letak kat sini. Kita try buat kat sini lah. So you have 2, 4, 6 and 8. Right. So basically n equal to 4. So from 4 we want to form r equal to 3. Right. So we want to create 3 object out of 4 object. Right. And by looking at these 4 object, this is a different object, means distinct object lah. So now let's say out of 4 we want to create 3 object, right? So now the question asks us if repetition of number is allowed. So the first place, let's say you have 4 choices, right? The second place of digit, if repetition are allowed, so you also can have 4 choices, right? The third place also 4 choices. So by looking at this one, the first task you have 4 different object, second task you have 4 different object, third task also have 4 different objects. So by looking at the first formula, right, m multiply with n, right? So 4 multiply with 4 multiply with 4. So this one is 4 power of 3. So this one should be equal to 64. So this one if repetition is allowed. So means that you have the same value, the same alternative from the left to right. So let's say for B, if repetition of number is not allowed, if repetition of number is not allowed, so let's say I'm putting here. So you have 3 digit number, right? The first digit, basically you have 4 choices, right? Multiply. The third places, if you already picked number 2 for the first place, the second place you have 3 choices, right? Because the repetition is not allowed. Let's say you choose number 4 for the second place. The third place you only have 2 choices, right? So the 4 multiply with 3 multiply with 2, it should be equal to 24. So basically you have 24 possible outcome to choose 3-digit number from 4-digit number when the repetition is not allowed, right? Now look at the example number 7.32. For how many number greater than 300 can be formed from 1, 4 and 6 if repetition of number is allowed? Now, so you have 1, 4 and 6. 1, 4 and 6 greater than 300 should be, let's say you want to create 3-digit number, right? Greater than 300 means 3-digit number lah. 1, 2, 3, right? So if you want to put 1 here, the first digit number is 1. This is not greater than 300, right? 4, 6 or 1, 6, 4. You have 2 possible outcome. If the first digit number is start with 1, right? It means that the number is not greater than 300. So basically, if you want to make a number greater than 300, you only have 2 choices, either 4 or 6. So the first digit number should be 2. You have 2 choices, 4 and 6. The second digit number, if greater than 300, it can be either 1, 4 and 6, right? So now you have 3-digit number. So you have a 3 possible outcome for the second place. For the fourth place, if the repetition are allowed, so you can also have to use for a 3-digit numbers. So this one should be 2 multiply with 3 multiply with 3. So this one should be equal to 18. So you have 18 choices to choose from 1, 4, 6 to form number greater than 300. So if the repetition is not allowed, same as before, the first number should be 2. 2-digit only. So either 4 or 6. Right? If we already pick 4, you only have left 1 and 6. If you pick 6, you only have left 4 and 1. So the second place should be 2 possible outcome. When you already pick these 2 digits, 4 and 6, for example, right, you only left 1 digit, right? So this one should be equal to 4. So you have 4 possible outcome to form from a number greater than 300 from 1, 4 and 6 if the repetition is not allowed. So far, by that explanation, do you understand? Ada faham ke? Right, very good. Now, we look at example number 7.33. Right. For example number 7.33, how many 4-digit number can be formed from 3, 5, 6, 7, 8 and 9 if the repetition is not allowed, and if repetition is not if allowed and repetition is not allowed. So now I'm giving you 2 minutes to solve example number 7.33. Can you do it by yourself, this one? Can you do it now? You have 2 minutes to solve this one. Okay, boleh dapat? So how to answer 7.33? A, if the repetition is of number is allowed. So what is the answer?
432.
4, 3,
32.
right? 4, 3, 2. For the second one, if repetition is not allowed,
120.
120, right? Very good, right? So the concept of calculating this value are same as 7.32, right? Now, example number 7.34. This is how many different questions can be answered from 10 question, right? So this is basically a combination question. So out of 10 question, which is n equal to 10, we want to select our 5 question, right? We want to select 5 question out of 10 questions. So how many? And then another condition from this statement is order is not important. It does not tell us whether order is important. So we assume the order is not important since it not mention the importance of the order of arrangement. So we should use 10 choose 5. So this one should be equal to 252, right? Now, example number 7.35. So this is going to be a bit calculative, right? So in example number 7.35, right? So I put here. So a club consists of 20 members, whom 12 are men and 8 are women. So 4 persons are to be selected as committee, right? But wait, this is a probability question, right? So we're going to hold these 2 questions for later, right? So until we learn probability, right? So we will learn probability in short while, right? And then we will come back to this example, right? Because this is an example for probability, right? So far, today we already learned four equation, 4 formula basically. The first formula is m multiplied with n. The second formula is the same formula as 1, but if you have a repeated or same task, right? Same possibility of the possible outcome for the same task for n different types. So you boleh pakai r power of n. So the third formula is when you have n different object, you want to rearrange is n factorial. And number 4 formula, which is when you have a repeated object, right, n factorial divided by r1 factorial until rk factorial. And then we also learn permutation and combination. The difference between the same of permutation and combination is when we have n different object, we want to select r object from n different object, right? So that is the common thing in permutation and combination. The difference between combination and permutation is the permutation, we apply permutation when order is important. We apply combination when the order is not important. That's the difference between combination and permutation, right? Now, just sekali lalu saja untuk set theory, right? It's not my intention to teach you set theory, just a review on set theory. I believe that you already know and already learned set theory in the school, right? Now, just a review, just for a reminder to refresh your knowledge on set theory, right? Set theory is a set of group of a set is a group of object. A set is denoted by capital letter A, B, C, D, E, F, G until Z, right? So set is denoted as capital letter, and set is written by bracket. So let's say A is a set, right? So you ada bracket dekat sini, right? This is considered set, right? If you don't have the value here, so this is what we call as empty set or null set, right? So the value inside the set, let's say A equal to 1, 2, 3, 4, 5 and 6. This value we call element of a set, right? So now this is the first part, introduction of the set. The second part, an intersection of two set A and B is the set of all elements belong to both A and B, right? So the intersection symbol is this one, right? This is look like N, right? Terbalik or U-turn, right? Let's say we have set A equal to 1, 2, 3, 4, 5, 6, or let's say I letak set A is equal to 1, 2, 3, 4, 1, 2 and 3, right? And set B we have 4, 5 and 6, right? So let's say we want to find intersection between A and B. A intersect B, it should be all elements belongs to A and B. So all element in A, 1, 2, 3, all element that belong to A and B, for both A and B. So means that all element yang ada dalam A and B. So kalau kita nampak dekat sini, A and B, 1, 2, 3, and A is 1, 2, 3, B is 4, 5, 6. So tak ada benda yang sama, right? All element belongs to both A and B. So means that there should be nothing in common, right? Means that intersect mean we want to find element that have in A and also have in B, right? They are in A and B. So let's say I put set C is equal to 2, 5, 6, right? So if you want to find A intersect C, right, A and C, so we have element 2 in A and also in C. So A intersect C should be only 2, right? So this is just the symbol for an intersection. So if you can look at example this one, if A is equal to 5, 3, 8, 9, 7 and B is equal to 4, 8, 5 and 9. So A intersect B is the element that belong in A and B. So we have 5 here and then we have 8 here and we also have 9 in common. So that's why A intersect B is 5, 8 and 9. Right? So union is of two set A and B is a set of all element belongs to A or B or both A and B. So the notation of union is U. You turn U. Right? If you want to find A union B, right, it should be the combination of these two element in set A and set B. So it should be 1, 2, 3, 4, 5 and 6. So this is the symbol for the definition for union set. For example, let's say you have A, 2, 4, 6, 8 and B you have 1, 2, 3, 4 and 5. So A union B should be 1, 2, 3, 4, 5, 6 and 8 lah. Right? So this is just a review. I hope you will do your own revision to further understand set theory. Right? Because we're going to use set theory thoroughly on introduction to probability. Right? Now, a complement set. A complement, the symbol of complement is A complement, A prime. Or we can use AC, right? Either symbol, either way also works, right? So in my class, I would like you to use A prime to indicate complement of set A. So a complement means a complement of set A is the set of all elements that not belong to A, right, but belong in the universal set U, right? A complement of A is denoted as A prime. So kita pakai A prime lah. So let's say you have a sample space. So I belum sebut lagi apa itu sample space, but before we go to complement set, we shall touch about sample space. Sample space, the symbol for sample space is S. Sample space is a complete set of all element in one experiment. Right? If you roll a die, right, it's all possible outcome in one experiment, right? If you roll a die, right, die you have 6-sided die, right? So we should have all possible outcome 1, 2, 3, 4, 5 and 6. So this is all possible outcome in one die. So sample space is all possible outcome in one experiment, right? So this is what we call as a sample space. So now let's say I'm rolling a die. Set A is equal to, I am rolling a die 3 times. Let's say I got 1, 3 and 6, right? So this is A. If I want to find A complement, so means that the value of the element of A, the element of that not belong to A but ada dalam sample space. So A dah ambil tadi 1, 3 and 6. The complement is, mean yang tak ada dalam A is 2, 4 and 5. So this is a complement 2, 4 and 5. Right? Hope you understand this one, because this is just a review. I want you to review by yourself later balik nanti ada habis kelas nanti you review balik sendiri and make sure you fully understand what is the definition of interset, set, union, complement, null set, Venn diagram and so on. And number 5, two sets A and B are said to be disjoint or mutually exclusive if the two sets have no element in common, such as A intersect B is empty set. So now if you look at this A and B, this set, these two sets A and B. So set A we have 1, 2 and 3. Set B we have 4, 5 and 6. So that's why intersection of A and B is a null set, right? It's a null set, right? So means that these two sets are mutually exclusive. There are no intersection between these two sets, right? So that's why we call it as mutual exclusive event, right? Mutual exclusive set. So if you look at A and C, we have intersection A and 2, which is 2, right? So this is A and C are not mutual exclusive event because they have intersection. So easy to remember, mutual exclusive event means there are no intersection between two sets. Non-mutual exclusive event means there are intersect between these two sets, A and B, right? So Venn diagram, this is a Venn diagram, number 6. Venn diagram is a diagram used to portray the operation on set. So we draw set A, this is set A, and this is set B. If, by looking at this one, this is not U, this is S, right? The area on the shaded area ni, dekat sini, adalah intersection between A and B. A and B, right? And this is a Venn diagram, right? Set A and B. So if you look at this one, A and B have a intersection. When A and B have intersection, we can say that A and B is not mutual exclusive event, right? So this is showing this Venn diagram showing set A, and this is sample space, and outside of A is we call as a complement of A, right? And for this one, set A and B, right, does not have intersection, right? Dia tidak ada intersection dekat sini, tak bercantum dekat sini. So means that this A and B are mutual exclusive event. So A intersect B here is a null set or empty set, right? So basically this is the review of set theory, right? And I think I ada lagi benda-benda lain yang I tak sebut dekat sini, right? But basically nanti basically your task is to find out the balance, the remaining knowledge on set theory, such as rule. We have rule of addition. Rule of addition, let's say A union B. So A union B minus B intersect A, right? So this is the rule of addition. Rule of multiplicative, A intersect B is also equal to A multiply B, right? Or B intersect A is also equal to A intersect B. A multiply with B, right? So basically, the rule of addition, we have I am going to leave you one homework. Try to find De Morgan law, right? Try to understand De Morgan law, right? Because De Morgan law is very important. If you start with anything, then you can solve the problem using De Morgan law. I think in here I not providing the law. You can find it De Morgan law. Tak ada, I tak tunjuk. But later on next class tomorrow, I will show you the Morgan law and some additional rule of set theory. We have multiplicative theory, multiplicative rule, addition rule, and then rule of let's say A union A, it should be equal to A, right? You should know the rule, the law of in set theory, right? And especially you need to understand De Morgan law, right? De Morgan law is very important. Please do a revision on De Morgan law, additional rule, multiplicative rule, and so on, right? So I think that's all. It's too much today, right? If you want, I want to continue. So basically, please do a revision on set theory, right? Please Google, please find a book, right, to do a revision on set theory. This is very important, right, for you to understand set theory before we move to probability, right? So far, if you have any question, please raise a question now. Ada soalan ke? Do you understand? Please comment on chat box. Mana yang lain ada 72 orang, hanya reply orang yang sama 45 orang saja. Yang lain-lain buat apa tu? And don't forget to sign in your attendance today, right? Yang mana datang, yang mana tak datang, tulis attendance juga. So I akan penalize sikit lah. Right, since you don't have any questions, so we shall stop here. Right, I think that's all for me today. So basically today we already learned a few method, right? First is counting rule, right? We have 4 formula that we already learned, and then we already also look at the permutation and combination. A lot of example we already looked today, and then we also look at review on set theory, right? So make sure you enhance lagi your understanding on set theory. Try to find De Morgan law. This is very important, right? And then tomorrow we will continue on introduction to probability. We will try to finish introduction to probability until Bayes theorem, right? I think that's all. Thank you very much. Assalamualaikum.